Hi students and friends, welcome to the channel Learn and Teach by Ayaz. I will continue my video lesson for the topic moles. I am already done with the empirical formula and molecular formula from given appropriate data. In this video, I will continue my lesson for doing some further calculation involving the calculation of or deducing the molecular formula through the given appropriate data. So the learning outcomes for this lesson is calculate empirical formula and molecular formula given appropriate data. Now here's a recalling. So whenever we need to work out the empirical formula, then we will be provided with the percent of mass of the elements. We have to follow these steps. Divide the percent of mass of the given elements by its AR. Divide the answers or moles obtained by the least value. Multiply the values to get the values in whole numbers. Now, how we can work out the molecular formula from the given data? We'll use this. N is equal to molecular formula mass divided by empirical formula mass. We'll get the answer in whole number, and then we'll multiply that whole number with each number of atoms in the given formula. Question number 1. A compound contains 0.5 gram of H and 4 grams of O. Calculate empirical formula. If molecular mass of the compound is 18, work out its molecular formula. We have H and O. The mass of H is 0.5 gram. We know the nucleon number of AR of hydrogen, which is 1. The mass of oxygen is 4. We'll divide the 4 by the AR of oxygen. You can see here, it is 16. So we will divide it by 16. Now dividing these values, what we will get? For hydrogen, we'll get 0.5. For oxygen, we will get 0.25. 0.25 is a small number, so we'll divide both the values by 0.25. For hydrogen, we'll get 2. Oxygen will get 1. So the empirical formula will be H2O. I'm writing the empirical formula here on top. This is the empirical formula. The molecular mass of the compound is given, and that is 18. Now let's work out the value of N by dividing the molecular mass by empirical mass. Empirical mass is the mass of the empirical formula. If you work out the empirical mass of this H2O, you will get 18. So 18 divided by 18 gives 1. So we'll multiply 1 by each number of atoms present in this. So the molecular formula will be H2O for this. Question number 2, find the empirical formula and molecular formula of a compound containing 51.28% carbon, 9.40% hydrogen, 27.35% oxygen, and 11.97% nitrogen. So we have carbon, hydrogen, oxygen, and nitrogen. Further, the molecular weight or mass of the compound is 234. So first of all, we will work out the empirical formula. Carbon, the percentage is 51.28. We know the AR or nucleon number carbon, which is 12. For hydrogen, we'll divide 9.40 by 1. Oxygen, 27.35 divided by 16. Nitrogen, 11.97 divided by 14. So carbon, 51.28 divided by 12, you'll get 4.273. For hydrogen, we'll get 9.40 because 9.40 divided by 1 gives 9.40. For oxygen, 27.35 divided by 16, we will get 1.709. For nitrogen, 11.97 divided by 14, the answer will be 0.855. So 0.855 is the smallest number, so we will divide all the values by 0.855. I will continue the calculation on the next slide. We have carbon, hydrogen, oxygen, and nitrogen. For carbon, what we will get? When you will divide 4.273, 0.855, you will get 4.997. 4.997, which will become 5. So we'll write 5 here. What about hydrogen? 9.40 divided by 0.855. 10.99. 10.99 means becomes 11. So for hydrogen, I will write 11. For oxygen, 1.709. 0.709 divided by 0.855. 1.998. 1.998, or it becomes 2. Nitrogen, it's easy. 0.855 divided by 0.855. We will get 1 here. So for oxygen, it's 2. For nitrogen, it's 1. So the empirical formula will be C5H11O2N1. Now we need to find the molecular formula. In order to find the molecular formula, we need to divide the molecular mass by empirical formula mass. The molecular mass will be calculated from this empirical. The empirical mass will be calculated from this empirical formula. There are 5 atoms of carbon, so we will multiply 5 by 12. You will get 60. For hydrogen, you will multiply 1 by 11. You will get 11. For oxygen, you will multiply by 2 by 16. You will get 32. For nitrogen, you will multiply 1 by 14. You will get 14. So now add up these values, what you will get? That 4 plus 2, 6, 6 plus 1, 7. 6 plus 1, 7, 7 plus 3, 10, 10 plus 1, 11, 117. Molecular mass is 234. So 234 divided by 117. 234 divided by 117, we will get 2. Multiply this number by each number of atoms in this empirical formula, C5H11O2N. We will get C10H22O4N2. This will be the molecular formula, final molecular formula for this compound. Here's another question. A hydrocarbon contains 90% carbon by mass. Number one, deduce the empirical formula of this hydrocarbon. First of all, you should know what are hydrocarbons. Hydrocarbon is a compound containing hydrogen and carbon only. So it means this hydrocarbon must contain hydrogen. We need the percentage of hydrogen in this compound. So percentage of carbon is given, just 90%. In order to calculate the percentage of hydrogen, we'll subtract this 90% from 100. We'll get 10%. So the percentage of hydrogen is 10. Carbon 90%, hydrogen 10%. So divide the 90 by 12 for hydrogen, divided by 1. For carbon, 90 divided by 12, 7.5. For hydrogen, we'll get 10. 7.5 is the smallest number. So we will divide both these numbers by the 7.5. For carbon, we will get 1. And hydrogen, we will get 10 divided by 7.5, 1.333. Now multiply to get the answer in whole numbers. I'm writing it again. Carbon, hydrogen, 1.333. If we will multiply 2 by 1.333, we will get 2.666, which is not whole number. So what we will do, we will multiply it by 3. So we'll multiply 3 by 1.333, we'll get 3.99, which means it can be round off to 4. So 3.99 or 4. For carbon, you will write 3. So the final formula will be C3H4. C3H4. This will be the final empirical formula. On next part, what additional piece of information is needed to deduce the molecular formula of this hydrocarbon? Molecular mass is required. Molecular or molar mass. Thanks for watching. Press like and share my videos. Give comments. For more videos, subscribe to my channel and press the bell icon.